In this lecture, I will introduce Echarts, a JavaScript library that makes interactive data visualization online. I will use Links Milestones Overview, a website developed for the Links project, as an example to showcase how to use Echarts. Echarts is a JavaScript library to draw interactive charts on the web page. It is an open source project from Baidu and a mature, commercially oriented product developed on industrial standards. Echarts utilize HTML canvas element for drawing. It provides 12 commonly used chart types and also offers 7 interactive components. I think the most important feature is that Echarts supports big data mode on the Cartesian type of charts. It can draw up to 200,000 data points in seconds with full interactive features. And Echarts is modularized. The link below will lead you to the Echarts official website. Let's look at the example web app. This app is basically an overview of the links data to be generated in the next few years. Since the links data focus on measuring the consequences of agent-perturbed cell lines, it is natural to plot the signatures by perturbation and cell line. The x-axis is perturbation in lexicographic order, grouped by perturbation type. There are 3 types of perturbations: 140 chemical perturbations on the left, 17 genetic perturbations in the middle, and 107 microenvironment perturbations on the right. The y-axis is cell line, also in lexicographic order. Each symbol on the chart represents a signature to be generated. The signature type and its generation center is encoded in the shape and color of each symbol. For example, a red square symbol means this will be an image signature generated by the HMS data generation center. Mouse over this square, you can see what are the cell lines and perturbations in this signature. So here it's the EGF perturbation applied on the WM115 cell line. The chart is interactive. For example, click the pencil icon. You can draw a line on the chart. And click the 2 icons on the right to delete or clear all the mark line. You can also zoom in the graph and click the next 2 icons to restore the graph. For example, you can zoom in only a very small part charts. You can still zoom in even further. And you can click this icon to zoom out and this icon to restore the graph to the original state. Click the last icon to download the graph as a PNG file. Click the icon, double click. It will be downloaded as a PNG file. In the rest of the slides, I will explain how to draw this chart using Echarts. I think the best way to learn how to program in JavaScript is actually to play with an example app and read its source code. So the source code of this app is hosted on this URL. You can follow these steps to install the app on your local computer and play with the app. The first step is to install Git and Node.js. If you don't know how to install these 2 softwares, just Google it. It is very straightforward. This slide shows the structure of how the lecture is organized. First, I will show you how to import and initialize Echarts on your web page. Next, I will show you how to configure the option object. All the information about the graph is encoded in the option object. I divided the options into two groups, those independent of data and those dependent on data. And last, I will show you how to set the option on the graph and how to use the API to interact with the graph programmatically. First, let me introduce a concept called AMD. If you ever wrote a decent size of JavaScript code, you would know that if the functions in file A are dependent on functions defined in file B has to be loaded before file A. But following AMD API, you can avoid this by writing your code in modules that can be loaded in random order. Basically, AMD, the asynchronous module definition API, specifies a mechanism for defining modules such that module and its dependencies can be asynchronously loaded. The module definition in an AMD API is usually like this. It is defined in a define function. ID is the ID of your module. Dependencies are the IDs of the modules your module depends on. The factory is a function where all the code about your module is written, and the function takes dependencies as arguments. For example, on the right, we define an alpha module that depends on full and a bar module. The full and the bar modules are passed as arguments of the factory function of alpha. In the factory function, full and bar were used to define the new alpha module. Obviously, AMD enables user to write JavaScript in an object-oriented fashion and helps eliminate definitions of global variables in the app. There are many implementations of AMD specifications. The most popular one is the require.js library, which is actually used to build the Coursera website. Echarts use a similar library called esl.js. An object-oriented app always has the main function at the entry point. In AMD, it is the require function. The files in the example app are organized in folders like this. First, we have app as the root directory. Under the root directory, we have the index.html page. Then we have three other directories: the data directory, the scripts directory, and the libraries directory. Under the data folder, we have the chart input.json, which stored the data to be visualized in our app. In scripts folder are the scripts which we write for our app. Under the libraries folder are the libraries our app depends on, including Echarts. All the code about the graph I showed you is written in the main.js file. The searchbox.js is another AMD module that implements the search function, which will not be covered in this lecture. You can look into the source code to see how it works. The require function in main.js is written like this on the right. First, we have a require.config function. The require.config is basically a mapping from the JS files on the file system to a module name so that the require function knows that echarts/echarts mean the echarts.js in the directory of libraries/echarts/build/dist/echarts.js. Notice that by AMD convention, .js is omitted after the file name, So echarts/echarts equals to echarts/echarts.js. The EC, ES, and SE are the imported modules for our echart library, the scatter component, and the search box. Then we use echarts.init to initialize a blank chart. There is a div tag in the index.html page with ID main. So document getElement by ID, select that div, and the echart.init function initialize the chart under the div tag. Option object encodes all the information about the chart, including data, metadata, color, label, title, and etc. The various pieces of information about the chart are registered as properties of the option object. These properties are also called options of the chart. The options configured in the example app are title, tooltip, toolbox, x-axis, y-axis, color, symbol list, and series. Use echarts.setOption to draw the chart after building up the option object. Detailed documentation about how to configure each option is available on the Echarts website. So to use the Echarts, you do not need to have a comprehensive knowledge about JavaScript. As long as you know how to build the option object, make an interactive visualization of your data is very straightforward. So the first option, which is the simplest, is the title option. There are 3 attributes for the title option: text, subtext, and appending. Text is a links milestone overview. The subtext is an interactive plot. You can see that the subtext is smaller and the color is gray. The panning of the title to the left of the graph, here we set it at 0. Tooltip access the pointer. So access pointer is a property of the tooltip option. The access pointer property shows the dashed cross lines that mark the current mouse position on the chart. The short delay specifies the animation time for the access pointer to appear. Here we set it 0 because we do not want any delay. There are 2 types of triggers: access or item. If trigger is item, only when you mouse over an item will the access pointer show up. Here we wanted the access pointer to show wherever our mouse is on the chart, so we set the trigger as access. The properties of the access pointer itself, like show, type, bind style, are straightforward. We just set a show to true to enable the access pointer, and we set the type as cross, as we can see on the chart, and we set the line style as dashed and the width of the line as 1. The next option is the toolbox option. Again, we use show equals to true to enable the toolbox. The toolbox defines the interactive components user can use on the chart. Here we define 4 interactive components or 4 features. They are the mark lines, the zoom, the restore, and the save as image. For each of these features, we also use show equals to true to enable them. Then I set the title property for each of the 4 features. For example, for the mark component, there are 3 buttons: mark, mark undo, and mark clear. The titles are the text that will show up when user mouse over the icons. For the mark icon, I set the title as enable or disable mark line. For the mark undo, I set the text as undo mark line, and for the mark clear, I set the text as clear mark line. By default, the titles for these icons are in Chinese, so I just translated them into English here. Obviously, all the previous options are independent of input data. The next few options will be dependent on data. So now let's look at the input data first. In the overview chart, each item is a signature with 4 pieces of information: perturbation, cell line, asset type, and center. We set perturbation as x-axis and cell as y-axis, so the position of each signature is uniquely determined by its perturbation and cell line. We then encode center as color and asset type as shape. In the input data, as you can see, there are 4 corresponding fields: parts, cells, series, center, axis, and the tooltip. The series is the actual data. Each signature is represented as a coordinate of 2 numbers, with the first number being the index of the perturbation and the second number the index of the cell line. The order of perturbations and cell lines that maps to the coordinates are specified in perturbations and cells. This perts equals to perturbation. Each perturbation object in perturbations has 2 attributes, perturb and per class. Each cell object in cells also has 2 attributes, cell and cell type. The coordinates are then grouped by center and asset, so that signatures of the same center and asset is grouped together in an array. The series is composed of several of these groups. The center and asset information in center asset arrays has a one-to-one mapping to the series groups. The tooltip is a helper dictionary that maps each coordinate to corresponding center and asset. To load the data, we use the jQuery function jQuery getJSON to load the input data asynchronously as the input variable. In this slide, we set up the x-axis. Since our input coordinates are numbers, so the type of x-axis is set to value. The name perturbation is the name of the x-axis shown on the rightmost. The formatter is the function that takes x-coordinate on the x-axis and formats it into an axis label. Here, the perturbation attribute in the input data comes into play. Input.perturbations v-1 dot perturbation get the perturbation name and the current position. We use v-1 because the index starts from 1, not 0 in the input data. The y-axis is pretty similar to the x-axis. We just changed the name of the axis to cell. Here, we set another attribute for the tooltip option. This is actually another formatter that will format the content that will show up when mouse over an item. The parameters argument is the coordinate of the mouse hovered item. Input perturbations parameters value 0, -1 dot perturbation, and the input dot cells parameters value 1, -1 dot cell are used to get the perturbation and the cell line name of the hovered item, which makes up the first line in the tooltip. The BR is a new line character in HTML. The input tooltip parameters value 0 and then parameters value 1 dot center axis gets the center and asset information of the hovered item that makes up the second line in the tooltip. The center color map and asset symbol map predefines color for each center and symbol for each asset class. The color and the symbol list option are both arrays of the same length as the input dot center axis, with color and symbol mapped to the predefined center and asset in the same order. Finally, we set the series option. The series is an array of several coordinate groups. Each coordinate group is defined by center and axis and has its own color and symbol. Each coordinate group is plotted as a group of symbols on the chart. Group.name specifies the name of the group. Group.type tells the Echarts that the data will be plotted as a scatter plot. You can see that only until here the Echarts realize that the chart to be drawn is a scatter plot, which indicates that you can mix group.type in the same series and draw different plots on the same chart. Here we only use scatter plot, so the group.type is the same for all groups. Group.data is the data in the group as defined in the input.data. Then the proteomic and the image if statement is used to customize the symbol size for proteomic and image symbol. At last, we push the build-up group object into series. Now we have finished building the option object, and we use the myChart.setOption, the option object, to set the option to the chart, and you should be able to see a scatter plot now. Echarts instance also provides API for customizing the interactions with Echarts from outside. The example code below triggers an item click event whenever an item is clicked and sends detailed info about the item to any registered listener. Okay, here is the end of this lecture.